Hi guys, so for today we will explain about technique of differentiation. For questions 1,
what is derivation? Derivation is a process in calculus to find the rate of change. It shows how fast and qualitative change, and answer must be called as derivatives. The important fact is like in physics, engineering, economy, and biology. For the physics, speed accelerations. For the engineering, is motion analysis. For the economy, is a profit and a cost. And lastly, biology is population of growths. For example, d over dx in square root in bracket x square equal to 2x.
This equation shows an example of differentiation using the power rule. The symbol d over dx means differentiate with respect to the x. The function inside the bracket is x squared. Using the power rule, we bring down the power, which is 2 to the front, and subtract 2 from the exponent. So x squared becomes 2x. This means the derivative or rate of the change of x squared is equal to 2x.
So we move to the technique of differentiations. The technique have 5 techniques.
First, this is constant flow. Here, d over dx means differentiate with respect to the x. The symbol C represents a constant number such as 5, 10, or 0. The derivative of constant is always 0 because constant number do not change. It is called power rule. The variable n represents the power of x. To differentiate, we bring the power in the front and the subtract 1 from the exponent. For example, x cubed becomes 3x squared. This is a product rule. It is used when two functions are multiplied together. We keep the first function, differentiate the second function, then add the second function multiplied by the derivative of the first function. This is called the quotient rule. It is used when one function is divided by another function. We multiply the denominator by the derivative of the numerator, subtract the numerator multiplied by the derivative of the denominator, and divide everything by the denominator square. And lastly, this is the chain rule. It is used when the function is inside another function. First, differentiate the outer function, then multiply by the derivative of the inner functions.
So for question 2, we need to find the derivative. For A, we need to find the derivative dy over dx for y equal to ln 2 plus x power of 3 sec 2 minus x. So for the calculation, first step, we need to apply the product rule. The formula for product rule is u prime v plus uv prime, where u in this equation will be ln 2 plus x power of 3 and v will be sec 2 minus x. Step 2, we need to find the derivative for u prime and v prime. So for u prime, the derivative is 3x squared over 2 plus x power of 3. Since the derivative for 2 plus x power of 3 is 3x squared, the derivation of v prime sec 2 minus x then 2 minus x. Since the derivative for 2 minus x negative 1. Step 3, we need to key in the equation using product rule. The result will be dy over dx equal to 3x squared over 2 plus x power of 3 sec 2 minus x plus 2 plus x power of 3 minus sec 2 minus x then 2 minus x. So if we simplify the equation, we will get the answer. The final answer will be dy over dx equal to 3x squared sec 2 minus x over 2 plus x power of 3 minus ln 2 plus x power of 3 sec 2 minus x then 2 minus x. So for question B, we need to find the derivative dy over dx of y equal to e power of 3x power of 2 over 10x. First, for the calculation, we need to apply the quotient rule. The formula for quotient rule is u prime v minus uv prime over v squared. For this equation, u will be e power of 3x power of 2 and v will be 10x. Next step, we need to find the derivative of u prime. So, the derivative of u prime equal to 6x e power of 3x power of 2. Since the derivative of 3x squared is 6x. For v prime, the derivative of v prime is sec square x. Next, using the formula of quotient rule, the result of dy over dx will be 6x e power of 3x power of 2 10x minus e power of 3x power of 2 sec square x over 10 square x. So, if we simplify the equation, we will get the answer. The final answer will be dy over dx equal to e power of 3x power of 2 6x 10x minus sec square x over 10 square x.
So for question 3, given cos 4, exponent to y minus x cubed equals to 4xy, find dy dx using implicit differentiation. So the first step we need to do is to split into 3 parts, which is A, B, and C. Cos 4 exponent y minus x cubed is a, negative ln y square is b, and 4xy is c. So first we need to differentiate d over dx, go to cos 4, exponent y minus x cubed. We moved the 4 to the back, and then we use the differentiation steps to differentiate the 4 to bring the front, and then 4 minus by 1, we got 3, and then we got 4 cos exponent to y minus x cubed, and then we differentiate sine cos, which is negative sine, and then we differentiate inside, so we got 2e to y times dy dx minus 3x cubed, 3x square, sorry, and then we times the 4 with the 2 exponent to y dy dx minus 3x square, and then we got this as the final for part A. For part B, d over dx equal to negative ln y square. We differentiate the ln y, got 1 over y square. Then we differentiate the y square, we got 2y times dy dx. So we got negative 2y times dy dx. And then for C, differentiate d over dx for xy. We use the product rule. So u is for x, u prime is differentiate the u, so we got 4, and then v is y, differentiate y, we got 1 times dy dx. So the final for the part C is 4y plus 4x times dy dx. And then we put all the equations back to the original forms, like this. And then we factorized the dy dx. We move all the dy dx to the left, and then we factorize the dy dx, and then the final answer for dy dx is 4y minus 12x squared cos e to y minus x cubed 3 sine e to y minus x cubed over negative 8 e to y cos in bracket e to y minus x cubed 3 sine e to y minus x cubed minus 2 over y minus 4x. Thank you.
For questions 4, the question asks, use linear approximation to estimate the value of 16.03 squared minus 1 over 4th root 16.03 correct to 3 decimal places. To begin, we extract the information given from the questions, which is the question asks us to use linear approximation, and the equation we get from the questions and the final answer must be in 3 decimal places. Let x equal to 16.03 be a value we want to approximate. We define x naught by select the closest integer from x. We choose 16 as our x naught because 16 gives us clean value when calculating with powers and roots. Then we minus x with x naught and we get 0.03. We set our general equation with fx equal to x squared minus 1 over 4th root x, and we rewrite it in index form, which is x squared minus x to the power of negative 1 over 4. Moving on into the next step, we need to find the first derivative of our function, which is f prime x. We differentiate x squared minus x to the power of negative 1 over 4, and it becomes 2x plus 1 over 4 x to the power of negative 5 over 4. Then we rewrite the equation with 2x plus 1 over 4 4th root x to the power of 5 to get a straightforward calculation. Next, we recall linear approximation formula, which is fx equal to fx naught plus f prime x naught multiplied by x minus x naught. We substitute x and x naught into the formula, and we get f 16.03 equal to f 16 plus f prime 16 multiplied by 0.03, as we already calculated before. With that value, we substitute with f and f prime, and it will be 255.5 plus 0.9602. And we get an answer which is 256.4602. And for the last step, we change it into 3 decimal places, and we get 256.460. To conclude our presentation, this assessment showcases the full utility of differentiation. We started by understanding its meaning as a rate of change. To solve all the questions in this assessment, we rely on recognizing which rule fits the structure of the function. We use the power rule for basic algebraic terms, the product and quotients rule when functions are multiplied or divided, and the chain rule for composite function. For the advanced problems, we apply implicit differentiation for more complex equations and linear approximation to estimate real values. All these techniques prove that differentiation is an essential practical tool in calculus. That's all from us. Thank you.